Let's do number 1 from the midterm review. In this, we're asked to graph the exponential function of y equals 4 times the quantity 2 to the x power. Now this is in the form y equals ab to the x power. These 2 points are going to be on the graph, 0a and 1ab. So what you need to do is figure out what's a and what's b, and then you'll have 2 of the points. You can also just pick some values for x and find out what y would be with an x, y table. If you need more help with this, check out page 478 through 479, examples 1 and 2.
Go.
This is for midterm review number 2. In this problem, you're told an initial population of 895 quail increases at an annual rate of 7%. Your task is to write an exponential function to model the quail population. The group that did this said pages 480 through 481 will be helpful. On those pages, they give you the general form of an exponential growth model. Y equals a times 1 plus r raised to the t power. Now in this formula, a is initial amount, r is rate, and t is time. So what you need to do is look back at the original problem, try to figure out what a, r, and t are, and plug them into the formula. On number 3, we have a big long word problem. Suppose you invest $1,600 at an annual interest rate of 4.6% that's compounded continuously. How much will you have after 4 years? Now, information about this problem can be found on page 494. But before we jump into the continuously compounded interest formula on page 494, let's just look at the 4 answers here. Are any of them reasonable or unreasonable? For instance, is after 4 years of investing, having less money a reasonable answer? Are these reasonable answers? Is this last one a reasonable answer? Perhaps we could answer it on that alone. Otherwise, we're going to need to go to page 494 and use the formula. For midterm review, problem number 4. Here, we're asked how much money invested at 5% and compounded continuously for 3 years would yield $820. Now, you can get specific help for this problem on page 494. But let's try to eliminate some of the answers here. If you put money into an interest account, it earns money each year. The amount of money in the account grows. So in this problem, it's saying, how much did you start with? And you're going to end up with $820. That means you couldn't have started with $952. That's more. That would mean you're losing money to get down to $820. So we know it's not A. $818, while this value is less than $820, it doesn't seem very reasonable that it would take, after 3 years of your money being in the account, you only earned $1.16. So I'm going to say B is a little unreasonable too. Now 780 and 705 are both reasonable guesses. They're both less than 820. But the good news is, if you just guess C or D, you now have a 50% chance of getting this problem correct. Before you eliminated these, you only had a 25% chance of getting it correct. So I'll let you try to figure out if it's C or D using help from page 494. This is midterm review problem number 5. Now this group, their task was to write the equation in logarithmic form. Right now, this is called exponential form. They said you can get help for this on page 499. So if you look on 499, it says exponential form is written as b to the x equals y. Our goal is to write it in logarithmic form, which is log base b of y equals x. So you want to match pieces of this with the exponential form and convert it into logarithmic form. And this is a fish. This is for midterm review problem number 6. Here we need to evaluate the logarithm of log base 5 of 1 over 625. Evaluate means, what does this equal? So we'll say this equals something. Now you can get help for this problem on page 541. What we're going to want to do is convert this from logarithm form to exponential form. So 5 to what power equals 1 over 625. Good luck. This is for midterm review problem number 7. Our goal here is to write the equation log base 32 of 8 equals 3/5 in exponential form. The group in second period that did this problem says page 517 will be helpful in doing this problem. In fact, they even gave you more information. This is exponential form here, and this is logarithmic form. They used colors to indicate where the different pieces of exponential and logarithmic form go. So this is in logarithmic form. What would it look like in exponential form? This is for number 8 from the midterm review packet. Here we need to write the expression as a single logarithm. Now the group who did this problem said you can get help on page 508. That's section 7.5 in our book. Now, there's a lot of things going on here. It looks like we're going to be using both the product and the power property to smush all of this in, to condense all of this in to a single log expression. Right here, let's just look at this first term. This 5 in the front, according to the power property, becomes the power of the q. So this right here can be written as log base b of q to the 5th power. What you need to do is figure out what to do with this term and then figure out how to combine them. All right, this is for problem number 9. Now we're asked to expand log base 7 of n over 2. The group that did this problem said you can find information about it on page 507 of your book. And specifically they said the quotient property would be useful. Now what does expand mean? It means rewrite this logarithm in an expanded form. In other words, break it up. How can you break this up? Number 10 from the midterm is simplify the natural log of e cubed. Now you can get help for this problem on page 501. Remember, the natural log is really just log base e of whatever the of number is here. So log base e of e cubed. Try converting this into exponential form and see what you get. Good.